All right, y'all, we have 2 quick videos going today, so please make sure you've watched the Desmos one and also this one. The order does not particularly matter. Okay, so we're talking more about correlation, and we'll also be talking about causation in a minute, but I want to go to 3 real-world examples of correlation. We've looked at what they look like on graphs, but I just want to talk about how that plays out in real life. So here's an example of positive correlation, size and price of a house. So the 2 variables that we're looking at here are size and price. Size and price. Okay, so what I have here in red is that if the size is going up, the price is also going to go up. So think about it, the larger of a house you get, probably the more expensive it's going to be, right? So when this guy goes up, so does that guy. We call this positive correlation. And in the green, I'm showing, okay, well, what if the size goes down? If the size of the house is smaller, generally speaking, the price will also go down. It'll be cheaper. Okay, so basically you can see that if one goes up, the other goes up. And if one goes down, the other goes down. And again, when we saw this on a graph, it looked, the points that we are plotting looked something along these lines, right? There's generally a positive slope there. So you can see if one of our let's say that size was the x-axis variable, that's very small, and price was the y-axis. As the size increases, right here, this red scenario, the price also increases. And if the size decreases, so over here when we have smaller sizes, you can see that the price is also smaller. Okay, negative correlation, here's another example. Let me get the right colors in here. So this is kind of the opposite in a sense, the weight of a car and the gas mileage. So in the red scenario, if the weight of a car is higher, so it weighs a lot, that usually means that the gas mileage is pretty low, this red scenario here. And then on the other hand, but if the weight of a car is low, then probably the gas mileage is actually high. So you can see that in this scenario up here with positive correlation, whatever's happening to one variable, the other variable is going in the same direction. Here it's the opposite. If this variable is going up, this one's going down. If this variable, on the other hand, is going down, this one is going up. And again, we can see this, and we've seen this on our graph. It looks something like this, where we have that downward trend. So if we imagine this to be the weight and this to be the gas mileage, as the weight gets larger, so over here, you can see that our points are lower on the mileage area, which means that they have lower gas mileage. But as the weight gets smaller, so over here closer to 0, you can see that's when our dots are actually plotted higher up, meaning they have higher gas mileage. All right, and finally, 0 correlation. Here's the scenario. Your height and how many siblings you have. Well, there's really no pattern there. Your height and the number of siblings you have don't really follow a pattern or have anything to do with each other. And that's what brings us to this discussion of correlation versus causation. So sometimes, depending on what you're looking at, you might have a scenario in which it looks like the variables are related. Maybe you have something like this, right? So this clearly is a positive correlation. But just because there's a pattern here, it doesn't mean that one causes the other. Okay, so let's look at an example. Shoe size is apparently strongly correlated with reading ability. So what that means is that, again, this is a positive correlation, so look up here. If one goes up, the other goes up. If one goes down, the other goes down. So shoe size, if you have a higher shoe size, that would indicate that your reading ability is also higher. Okay, but what about if your shoe size is really small? that would mean that your reading ability would also be really low. Now, if you think about this as kids versus adults, I can see how you would say, yeah, maybe they are related, because when your shoe size is really little, when you're a little kid, you don't know how to read yet. But let's imagine that we're just talking about adults. In that case, if we're just talking about adults, there's no reason to think that my shoe size affects how I can read. So even though we see the pattern of a positive correlation, when one goes up, the other goes up, and when one goes down, the other goes down, that doesn't mean that the shoe size actually causes the reading ability. Okay, so that's the difference between correlation and causation. Correlation shows a pattern, but it doesn't mean that one thing causes the other thing to happen. Let's do one more example. This is also from the book, so I have not done this research myself, but apparently the number of fire engines responding to a fire is positively correlated with the total damage. So basically they're saying the more fire trucks there are, the more fire damage occurs. So again, this follows a pattern of positive correlation. One thing increases and so does the other. But this is not an example of causation. More fire trucks don't cause the damage to be larger, right? The fire trucks are there to assist and to help put out the fire. So the fire trucks are not actually causing the damage themselves. So this is not a causation. This is a correlation, right? Because one goes up, the other goes up, so it's a positive correlation. But if we're trying to figure out if it's causation or not, that's when we kind of need to use our common sense. We would say, no, it's probably not the cause. The reason that these two are positively correlated is probably because more fire trucks are sent to larger fires, and larger fires are what cause more fire damage, not the fire trucks themselves. So hopefully that makes sense to you guys. Again, just make sure you've watched this video and the Desmos video, and then you'll be ready to do today's exit ticket.